Hello everyone. This is Priyadarshini, Assistant Professor from the Department of Food Technology, Hindustan College of Engineering and Technology. So, today we are going to see about one of the interesting topic. If you see the slide, there will be a symbol. It indicates the radura symbol. That means we are going to see about irradiation process. So, before that, I want to share a few thoughts about food preservation. Why? Because we want to preserve the food for our survival, because food is the major component for the human survival. So if you want the food to be fresh all the time, you have to choose the best preservation method. So there is various types of preservation methods that is listed out, like adding salt, sugar, dehydration, vacuum packaging, canning, refrigeration, pasteurization, adding acidic. So there is lot of food preservation method for this storage of foods. So why we are preserving food? We want the food to be fresh, and also we want to extend the shelf life of food. So some foods we want for long time, prolonged time. So that time we need some processing method. So by using that processing method, we can able to extend the shelf life of the product. If you see this slide, this is ancient methods and this is modern methods. So ancient methods is nothing but the salting, smoking, drying, fermenting. You all know that drying method, salting method, smoking method, because ancient times also, nowadays also, people used to dry something in sun using sun. So it's known as sun drying. So these are some ancient methods. So these are also basic methods of how preservation emerged. So these are modern methods: freezing, canning, refrigeration, pesticides and preservatives. So these are all some methods of preservation. So these are all emerging methods. So now we are all focusing on the emerging methods of food preservation. So food processing. So there is some methods like high pressure processing, pulsed electric field method, microwave, radio frequency, home heating. So there will be two types: non-thermal, thermal, using heat and using non-heat. So the only difference is using heat. So another one thing is these are all less time. So cost effective but less time. So here we are going to see about irradiation. So in the word radiation, so if you hear a word radiation, okay, if radiation is exposes to human beings, it will cause some effects to the humans, we all know. So a radiation, a rays. So if we are telling the radiation is harmful to humans, how we are using the radiation in food? This is the question, we all know. So if we eat some irradiated food, is it safe to eat? Okay, these questions are all myths, because there will be a beautiful scientific theory behind this. So first, what is irradiation? So irradiation is nothing but exposing food to a controlled amount of energy in the form of high speed particles or electromagnetic radiation. So every process has one source, like sun drying or smoking or anything you can take. There will be one source, that is heat. So in this type of process, there will be a source called electromagnetic radiation. So in the electromagnetic radiation, we are particularly including the ionizing radiation term. What is ionizing radiation? Some particles will bombard to the radiation. It will produce some ions. So in that ionizing radiation, here comes X-rays, alpha, beta, gamma. What are all this? These are the components, these are the sources we are using in the irradiation process. So like cobalt and cesium, these are all sources from gamma, radioactive compounds. So we are using cobalt and cesium for this irradiation process. So next, ionizing radiation is used to describe this various types of rays. So for this X-ray, beta, gamma, so from the gamma, the radioactive compounds like cobalt, cesium, these are all come under the ionizing radiation. So if you are see this, the range between the gamma, X-ray and ultraviolet, the difference in the radiation. So it's a process whereby food is exposed to a carefully measured amount of intense radiation energy called ionizing radiation. So the question is, why are we irradiating food? What is the need? So studies telling that first irradiated food was given to astronauts. So why? We want to extend the shelf life of food, and we want the food to be fresh all the time. So we want to preserve the food, because for the because we need food during our food scarcity. So how does food irradiation work? So how it actually work? So ionizing radiation as energy capable of producing ions. I already told about that point. If anything bombards to this radiation, it will produce some electrons or ions. So it is a capable of producing ions and other transient reactive molecular species when collision occurs. So like electron, hydroxy group and hydrogen. So these reactive species are capable of degrading and altering biopolymers such as DNA and protein. So ionizing radiation, what it will do, it causes DNA damage directly. So high energy radiation causes fragmentation of DNA, inhibiting bacterial enzyme and DNA destruction. It will lead to microbial growth. This is how irradiation destroys microbes and will give the microbial free food. So why, what is the need means, it will improve microbiologically safety by reducing infestation of dried spices and dried or fresh fruits and vegetables. It will inactivate parasites in meats and fish, and it will eliminate spoilage microbes. So another point is, the major point is, it will extend shelf life for foods. How? It will sterilize foods. So it will also reduces the use of chemical fumigants and additives. We are preserving some food, we are bottling some food, or means it is a need to add some chemical preservatives because we want to extend the shelf life. So this process will reduces the use of chemical fumigants and additives. So next, the major thing, the process of irradiation. So first, the simple concept we have to understand is, it is a very simple process. First, a packaged food is passed under the source of irradiation at a certain speed to receive the desired amount of dose. Sources of ionizing energy can be gamma rays from cobalt and cesium. In United States, cobalt is mostly used. So in India, what we are using? So cobalt and cesium is the permitted, and we are using from the gamma. So gamma radiation does not elicit neutrons, particles conferring radioactivity, and thus foods and packages are not made radioactive. So what is the thing means, if in this point I mentioned about dose, we'll see about in the next slides. So first, this is a process of irradiation. This is how it will look in this radiation process chamber. So if you are seeing some of the operation modes, continuous and stationary, concrete walls, transport mechanism, radioactive material, water pool, sliding and rotating concretes. This is a myth, is that if you are having any more heat particles or heat system, you have to place in between the waters. It will make you some cool or manage to not to increase their temperature. So that's the same thing here also. The radioactive material, if you see the radioactive material, we like use cobalt and cesium, we are keeping under the water, so it will reduce some heat. So if you can see the stackage, first in the stackage, so it will stack, if you see the stackage, it will, in the food is packaged, the pre-packaged food is gone through the treatment chamber. So in the treatment chamber, there will be a radioactive material which is placed under the water pool. If it is not used only, it will be placed under the water material. So otherwise it will be used, the radiation will be there, the cobalt and cesium sources will be there. So after it will so automatically we already studied that, I already told that if the radiation will destroy the microbes. So how it will destroy it directly destroy the DNA. So we'll get the microbial free product. So I told that the dosimetry, right? So what is dose? Every process will need optimum pressure or optimum temperature or optimum dose to run a process. So in that dosimetry, in that irradiation, dosimetry is the thing. Dosimetry means how much dose we are giving. Dosimeter means how we are measuring and monitoring it. So in this irradiation, dose is measured in gray. So where 1 gray is equal to 100 rad. So it will differ for different things. Pest, bacteria, so virus, so it will differ for different things. So some bacteria will have smaller DNA, so it will have 0.3 to 0.7 kilogram, or bacterial spores, some will be resistant, more resistant, then we have to give some more gray. So this is commonly irradiated products dose and purpose. So they are given that approval year, food dose and purpose. So wheat flour we are using 0.2 to 0.5 kilogram. Why we are using? We are using the purpose for the control of mold. So likewise they are listed out the food for pork, fruits, poultry, meat and also. So the approval here also, so we are majorly using radiation source, then we have to get the proper approval from the USDA and FDA only we can able to move the process. So these are all about irradiation. I hope you understand. So thank you for watching this video. Thank you.